to Aparna, who is the education chair for the Raleigh section, and she will introduce you to our panelists and our speakers.
Thank you, Christine, for the kind introduction. Again, my name is Aparna Strelick, and I am the Education Committee Chairperson for the IES Raleigh section. And today, I'm happy to introduce the topic for today. Of course, any IES program would be incomplete without a bit of levity. If anybody's experienced any of the IES presentations from the national section in the past, there's usually a bit of humor in the learning. So we'd like to keep that going in our section as well. Again, today's topic is the good, the best, the better, or best and better luminaires. Just taking off a spin from the good, the bad, the ugly. Just in reverse. Anyway, what we're looking to do in this section is to talk about what to look for when selecting downlights and troffers with a panel discussion. And in today's session, we will only focus on the troffers and downlights. Those two categories, and evaluating in terms of the overall construction materials that are used to manufacture these luminaires, options, lifetime, installation, and serviceability. So we'll touch on all these topics. A quick review of the agenda. I have just a few slides to introduce the topic, and then I'll turn it over to Amanda Height, who is also a member of our committee. Amanda will introduce the panelist and guide the session in a live panelist perspective related to good, better, best, and lead the Q&A section. We have two manufacturers and one professional engineers on the panel today, so we are delighted to have them. So let's get started. In deciding illumination for interior space with either downlights or troffers, there's a good chance you're going to need to consider the environment, the task, the overall project requirements, and budget. And to help kick off the topics, we're going to look at some troffer choices. And I say troffer choices or troffer type choices because the troffer segment has sort of exploded. It used to be just T5 and T8 fluorescent tubes as a light source set into a troffer or metal pan and a 2x2, 2x4, and a 1x4 in a ceiling grid for most commercial buildings. But when LED light sources entered the industry, now we got a variety of products to do basically the same work. No longer is a traditional troffer the only choice for designers. Got ceiling grid, surface mount, panel lights of many sizes, any size, array lit or edge lit, panel for ceiling grid, suspended in a light box, linear, and on and on. Same goes for the downlights. We have traditional recessed downlights, surface downlights, pendant lights, semi-recessed downlights, uplight, downlight, and just surface mount light. So the choices alone are just very dizzying. It is a confusing time. It can be like the wild, wild west in what you want to put into a commercial building. But it is worth saying that the LED technology has changed lighting products industry and opened new doors for creativity for sure. As I mentioned, there are just too many choices. But getting back to the good, better, best, I have 3 slides here that kind of give you the highlight or just the key things to think about when you are selecting a luminaire for space. You want to know what are the basic distinctions between good, better, and best. And one of the clues that you can tell what you're looking at as a good, better, and best luminaire is really in the name. So just starting at the name, you have, ultra economy, disposable, resi grade, contract grade, good enough. That kind of clues you in on this is probably in the good category. And also in the good category, there are a few options like, just color and CRI perhaps. They might be one-off and limited trim with just white color. So that kind of gives you another clue that it's in the good category. The warranty and life could be in the 2 to 3 year range. They are shorter lifespan. Material could be a light gauge sheet steel with possibly sharp edges, exposed screws, and overall kind of feels economical. Installation, there may be tools required for installation. You can probably notice some of the springs may be a little weaker, more difficult to manage, and definitely not easy to service or not serviceable at all would be the good category. In the better, couple things to key in on, of course, is the clue in the name: standard, professional, spec grade, commercial grade. You get more options, more CCT, CRI options, maybe some matching trims, different sizes, and warranty. Get a little longer warranty on the better side. For the materials, you go for a thicker gauge metal, maybe rolled or smooth edges, die casted. Maybe some non-yellowing plastic could be used, stainless steel or some powder coating, a bit easier to install, and maybe serviceable. It's hard to know sometimes in the better category, but this is definitely a step up from the good category. And finally, the best. A clue in the name would be premium or architectural grade or serviceable. Many more options, possibly tighter bend on the LEDs to have less color shift over time. More finishes and options to match with possibly the Troffer partner, so it all goes together nicely in the room space. Warranty can be longer, 5 to 10 years, or even more, if there's some servicing or a service contract with serviceable parts. Again, hidden screws for the materials, welded seams, thicker stainless steel, non-yellowing plastics, and the key one there could be sustainable materials in the best category. That also for installation could be hinged, easy to clean and service, and serviceability tends to be one of the key factors in the best category. So now I'd like to introduce Amanda Height, and Amanda will be the moderator for the panelist part of the program. Amanda has worked at Dewberry since 2006. She designs lighting and electrical systems for hospitals, particularly. And she obtained her LC certification in 2019, and she is passionate about designing systems that are a win-win-win for clients, design team, and end users. And she is also, thankfully, on the IES section education committee, where she jumped in right away with new ideas in the role. So welcome, Amanda.
Thank you, Aparna. I'm really excited about today's discussion. I think this is a wonderful topic, especially for early career designers, to understand what differentiates different fixtures. A lot of fixtures can look the same, but not be the same. So I'm really excited to dig in. Our panelists today, as Aparna mentioned, are from manufacturers as well as design side. So our first panelist, and I'll introduce them all, and then they'll each have a few minutes to speak about their perspective within the industry, and then we'll jump into some Q&A. Our first panelist is Marc Kassay. He is the COO of LumenFocus, which is based in Henderson, North Carolina. And they design and manufacture high-efficiency LED luminaires with a focus on UV germicidal for use in commercial and industrial, as well as healthcare and institutional applications. Our second panelist is Brad Roguero. He's vice president and founder of Helios Lighting. He previously spent 11 years with Hubbell Lighting as director of downlighting and new product development. And Helios is making downlighting easy to specify, purchase, and install and maintain. Our third panelist is Brad Watford. Brad has 21 years of design experience in engineering. He's currently with Siska Hennessy Group, and they work in specializing in pharmaceutical, biotech, research and development, and data centers. Brad is also a licensed electrician with 30 years of hands-on installation experience in residential, commercial, and heavy industrial sectors. So thank you all three for being here. And I will turn it over first to Marc Kassay.
Good afternoon, everybody. Thanks for joining. So I've been working with Troffers since, I guess, 1993 in the manufacturing side. Prior to that, I was in installation and electrical. So, you know, I think most of us would agree that Troffers and Downlights, not the most exciting part of our lighting world, but they are super important as they make up a large portion of the spaces that we light. And, you know, so selection of the product is really critical in a lot of instances. And then, you know, there are certain, you know, areas where maybe it isn't as critical. So we do have the good, better, best. That's why we're separating it out today. And I'm going to go over, you know, where I feel the lines are drawn from an application standpoint, where you might choose one over another. So yeah, you have a space, it might be a temporary space or a space that just requires some illumination, maybe a space that has budget constraints due to the value of the space being leased or sold. And so maybe that's where you're going to use the good product, right? It's not going to have a whole lot of options to it. It's just you know, what we might call a down and dirty product that is an off the shelf, or maybe a stock and flow product that you can easily get your hands on. And it just produces light for the space. Maybe not a lot of thought needs to go into it. It just needs to provide light. Then you move on to the better option. You know, you have a little bit more design flexibility. You have options of color temperatures, and you know, the fixture is going to be more robust with made out of it'll be riveted instead of snapped together, or it'll have a post paint versus a pre-finish. There's going to be, your edges aren't going to be as sharp. It's going to be a nicer product, and you can you have more flexibility in design with the better product. You might have options for dimming capability or basic controls. These are different features that you might find in the better product. When you get into the best product, you know, that's where we start thinking about, okay, this is, from a manufacturer's perspective, this is, you know, what we get excited about, because this is when a customer is bringing you their wish list and saying, hey, this is what we want. Can you put it together? It's going to have top quality products. It's going to be specifiable, even down to, say, the LED itself. You know, back in the fluorescent days, specifiers would specify as, you know, down to the brand and lamp model that they wanted in the particular product. You can actually do that with LEDs too. It's not as easy, but it's certainly an option. And we like to get involved in those design projects, and the ultimate troffer. I mean, it's really up to the creativity of the customer or the specifier. The material that it's made out of, it really depends on the application that it's going into. We can do troffers with wet location, or if it's a clean room product. I mean, there's so many applications that troffers are used in, and the materials have to be tailored to the use. In the best category, you're typically going to find that they're definitely powder coated products. They could come in custom colors. You'll have options like color tuning and controls, advanced control systems. From a manufacturability standpoint, there's a lot of flexibility and configurations that can be offered. And it's going to be the most specified product. So in other words, the majority of the options are going to be specified on the project. These products are going to have replaceable modules and programmable drivers, all serviceable in the field. And
great. So it sounds like there's a lot of choices out there and a lot of flexibility when you get onto that high end.
there is. The reality with LED product is that it is configurable in the higher end. The basic off-the-shelf products are going to be take what you get.
Okay, I think that's a great perspective to have. And now for a downlight perspective, let's toss it to Brad Rodeghiero.
Maybe I better unmute and start my video.
We'd love to see your face while you tell us about downlights.
There, did it start? There we go.
Yes.
If we could switch the screen to my slides, that would be wonderful. All right. So when it comes to downlights, as you go into the good, better, best, oftentimes when you get to the good, we're kind of in the downlight world talking about maybe the stuff you can get at Home Depot, maybe a little bit better. And that's, you know, generally not only is the construction going to be maybe a little less robust, but your feature set is going to be less robust as well. You're going to have kind of plastic painted trims. You're not going to have any sort of beam control and the whatnot. As we go into the better and best, oftentimes the differentiation, as with the Troffer discussion, is between feature sets. And, you know, today we didn't want to talk about different beam angles and optical control and things like that that differentiate the two. So a lot of the things that I'll be discussing today are really relevant for the better and the best. It's about the construction of the product and what things you should be looking for and expect in a product going into commercial or architectural high-end applications. First and foremost, you know, it seems obvious, but sometimes we all forget about it. LED downlights and products, LED products and lighting products, we're all excited because, you know, of the 5-year, maybe up to 10-year warranties. But a 10-year-old building is still a new building, right? So while it might be an old light fixture, it's still a new building. So a well-designed downlight can be serviced and maintained to last for decades. You should be able to look at the life cycle of a good product and say, hey, maybe just like a car, I got to change the oil and put on new tires, but the fixture itself should be pretty close to a 30, 40-year life cycle, should they so choose. Next slide, please. First and foremost, oftentimes we forget and we don't need to overthink it, but the frame of the product should be such that it's something that's consistent with a product that'll last for decades. It doesn't have to be overcomplicated, you know, but a solid, mechanically solid construction with decent bar hangers and such. You know, oftentimes this is the hand test, right? We pick it up and just does it feel like something. You know, as products get very, very competitive, this is often a place where people take cost out and oftentimes they go too far and you end up with something that, hey, it's going to last 5 or 10 years. But when you think about what a building goes through over the decades, the shaking and things like that, it can be important. Next slide. So when it comes to maintaining the product, the most obvious is the driver. And the fact of the matter is drivers fail, right? We can get, they don't fail like a CFL ballast or linear fluorescent ballast where we had maybe 2 to 5 years. You're going to easily get your 5 years, often 10, maybe more, but the driver is going to fail. It's going to fail first, and it's also going to fail off. You know, mostly it's the capacitor within the driver that's going to fail when it dries out. And then when the driver does fail, the whole fixture shuts off. It's an obvious failure. So when you look at how you're going to replace your driver in a downlight, if you're in a grid ceiling, maybe it's not so bad. You can always pop the next grid. As we remember, you know, on a recessed downlight, 90% of the fixture is above the ceiling. So in a grid ceiling, that's not so bad. In a drywall ceiling or a finished ceiling, that could be much more difficult. As we've gone from CFL to LED, our nominal aperture size have shrunk, right? We used to have 6-inch and 8-inch CFL downlights, right? You can get your hand up through the hole, especially with an 8-inch. Well, as you get to 3, 4, and 6-inch, apertures have shrunk because of some of the nuances and optical control of an LED versus a point source or a CFL. But the average size of your construction worker's hand or your maintenance guy's hand has not shrunk. So you think of somebody working their hand up through a 4-inch aperture, grabbing a driver and pulling it down below the ceiling, that can be tricky. And as you get smaller apertures, that can get even trickier. And the catch-22 is the smaller the aperture, the more likely it is to go into a finished ceiling. So as a specifier, that's just something to be very aware of. If you get into, you know, drywall work and paint just to replace a driver, it gets pretty tricky. The fact of the matter is, though, LEDs fail too. But in the vast majority of the situation, they fail last, often by decades. We have our prediction models with LM80 and TM21 to kind of predict how long our LEDs are going to last. But it's a long time, right? And the other thing about it is failure is arbitrary. You know, if over a matter of decades, I went from, you know, 80% lumen maintenance to 79% lumen maintenance, who knows that that's a failure, right? You know, it's a little bit arbitrary. It's not like a driver where the fixture shut off. And so as you go in there and consider what is the end of life on an LED, that gets tricky. And it's, as we know from HID lamps, that people have left in the fixture when they're probably down to 20% lumen maintenance, people don't replace them promptly. But the good thing about replacing a driver, when you put it in, it looks the same. When you go to replace LEDs, it gets very difficult. And that is because our LEDs, we have color shift over time, right? And it's kind of like when you smoke, or, you know, in the old days when you had smokers in the break room and somebody replaced one ceiling tile, and suddenly your nice yellowed ceiling tiles have a nice bright white one in the middle. And that's where it really gets difficult to change the LEDs in a single fixture, which makes it more important to be able to replace a driver in another fixture, because where the driver is the failure, we don't want to have to change the LEDs. Next slide, please. One of the often unthought about parts of downlights, and if you got to be a downlight geek to really appreciate this, is trim retention. You know, with LED fixtures, we love to talk about LEDs and drivers, and that's the big thing. But when it comes to actually making a downlight look pretty lousy in the ceiling, nobody wants a saggy trim. You know, I relate it to, you know, I have a teenager at home and I get really frustrated when he doesn't pull his pants up all the way. And when I see a downlight sagging in a building, I think the same thing. And the thing about it, it's not so easy and convenient to fix this, you know? So at the end of the day, in the CFL world, we called them grip clips. but it's basically a friction fit where you slide the reflector up into the ceiling, and you've basically got a little spring in there with some little sharp edges on it, and it holds it up. We love it because it's cheap, right? Well, unfortunately, it's cheap and it does a pretty lousy job. Now, if you have a CFL fixture and you're up there changing lamps on a regular basis, somebody can push that thing back up into the ceiling. Not necessarily so easy, by the way, because your whole fixture flexes, your T-grid flexes, and so you kind of got to hold it down and push it up to get it up tight against the ceiling. But with an LED, when it's kind of put it up there and forget about it for, you're hoping years, if not a decade or more, buildings shake. You know, we have thunder, we have HVAC systems, we have, you know, department get-togethers where people dance on the floors, you know, buildings shake. So over time, when it shakes, especially if you have a heat sink on top of that reflector, providing a little bit of weight, it's going to slowly sag down, and it's just a nuisance. Where if you can provide, you know, just a little bit of positive force, pulling that, kind of squeezing the frame to your ceiling surface, it's going to provide a much better fit. If you can't tell by my rant, it's something that I get a little bit uptight about. Next slide, please. And I believe the next one is my last one. And that's the other part, you know, when you buy a quality downlight, 90% of the fixture is above the ceiling, but 100% of what you're perceiving about that fixture is below the ceiling. And a high quality trim is a huge differentiator between kind of your off the shelf generic stuff to your good quality downlights, all the way from your better up to the best. You know, the guys that are selling the quote best and the highly architectural, this is what they're selling. And, you know, a spun anodized reflector looks really, really nice, but over decades, they can get damaged as well. And you still want to be able to avoid having to change the LEDs. So you want separation between the reflector itself and the LEDs. So if that trim that reflector gets damaged, you can easily replace it, right? You can go back to the manufacturer, say, hey, I need a couple, you know, reflectors, and they can put that back on, and you're good to go. They typically get, you know, damaged, either somebody, most often you get dust or cobwebs up there. Somebody well-meaning tries to wipe it down, you ruin the finish. All of a sudden it's a rainbow, it looks bad, you know, and you just want to freshen up the space. So that's the big thing. You know, when it comes to getting a downlight to last for decades, it's how do I service it? How do I replace the driver? How do I replace the reflector? How do I keep that reflector and everything snug and in place? And I believe I'm done. I don't think I have another slide.
No, you don't have any other slides. So
All right. Thank
move
you.
on.
All right, thank you so much. And now Brad Watford is going to speak a little bit about his perspective. Thanks, Attorney.
Yeah, hey, good afternoon, everybody. Yeah, so as a contractor and engineer, to build on what Mark and Brad have brought up, working across all the market sectors, right? So I've done residential work, some light commercial work, heavy industrial work, and from an engineering perspective, I focus in pharmaceutical and biotech design and construction oversight. So all the pictures that I put up are places that I've actually worked in, hands-on, you know, changing out lights, to even taking some wonderful parabolic Troffers to the scrapyard there. But it's just from a lighting perspective, as an engineer, you know, I look at everything from, you know, what is going to work best for the space, and then work best for product. So if you go to the next slide, some of the things that we focus on in the pharmaceutical and biotech world, you know, every building is going to have a mechanical room. Every building is going to have electrical rooms. You're going to have office space. You're going to have break rooms, when you start getting into clean manufacturing, where you have clean rooms, you'll have clean not classified, you'll have different ISO classifications for the amount of airflow. As the classifications go up, the amount of particulates in the airstream goes down. That's to better protect your product. So a lot of the things that I have to look at when I'm designing for luminaire thinking about the luminaire fabrication as it relates to the environment is a high lumen output. So we're usually looking at 75-foot candles or higher in some spaces. So we're looking for a high CRI. We want 90 CRI. Sometimes we'll go with 80, but it's we're always looking for the best we can get. We're having to do a lot of vial inspections, a lot of syringe inspection, and then as drugs and products come off the line, the labeling and the serial number inspections are key to meet FDA requirements. A lot of the times when we are dealing with pharmaceutical grade products, we have to get into UV considerations. Back in the day, when we had fluorescent Troffers in clean spaces, we had to use amber tubes over or amber sleeves over the tubes to filter out all the UV that could be detrimental to the product. Today, the good news is with LEDs, the wavelength below 400 nanometers is pretty negligible. So I don't have to be as concerned. Occasionally, we do run into products that have wavelength issues at about 450 to 470 nanometers. So we will go with amber LEDs to fix that. But the biggest thing that I have to look at for fabrication is airflow containment. We deal a lot with stainless steel housings. Sometimes it'll be cold rolled steel, but the heavier the gauge of the housing, the more air pressure that it can withstand. We'll use welded seams. Very seldom in a clean room environment do I use what I refer to as a punched fixture, just because I got to make sure that I'm stopping the airflow inside the housing as well as the gasketing. We'll use overlapping flanges on gyp ceilings. Sometimes we use overlapping flanges on sealed gasketed grids. But the main thing that we're trying to do is it's not only to protect the product and keep the product in the space, but also to keep the product from leaving the environment. A lot of times when you're dealing with pharmaceutical and biotech products, there's an active ingredient. And as we all know, none of us, not all of us are, I guess, what's the word I'm looking for? Protected from every active ingredient. So, like aspirin, you could be allergic to acetaminophen, and you get into an environment where acetaminophen is leaked into the workspace above the room, and you get it in your system, and we go up there the next day and find a maintenance guy that didn't make it. We never want to go into that type of environment. If you'll go to the next slide there. So besides, high levels of illumination and air containment, a lot of times we're dealing with electrical classification. So I'm looking at luminaires that can meet class 1, div 1 and 2 for flammable vapors, or class 2 for combustible dust. Even in some nutraceuticals and some food processing, you don't think about it, but flour and sugar powder are very flammable. So if they get into the luminaire and get on a driver, what I'm trying to do is protect the space and the people and the product from spontaneous combustion. The other thing that so we get into here is cleaning agents. So in the world that I design in, we use a lot of harsh chemicals. One that just rings a bell is called Spore Cleanse. That is some of the harshest chemical out there. It'll turn aluminum white almost instantly, which now I've got ashing then it'll eat the gaskets out of the luminaires. So when we go into these environments, we have to ask, what are you cleaning with? How often are you cleaning? And are you wiping it down? Are you hosing it down? Because, it's going to ultimately lead to product failure. So when I'm looking at the luminaires going in and thinking through all of that, it's like good, better, best. I tend to lean towards the best in that environment, just because of I don't want to go back and have to replace any parts. I don't want to have to break the seal on those luminaires. Just because if I break the seal, now I've got to shut down. The FDA considers that a contamination. So now I've got a filling line or a packaging line that can't operate because the FDA says I've got to shut down and clean. And that cleaning cycle could take a week, and then it has to be revalidated, which could take another week. So now we're down 2 weeks, and all because I had a luminaire fail. So it's kind of my take on the design aspect of it.
Well, thank you each for your perspective. Brad W., it sounds like you are going to lean towards what we would call the best. For designers out there who are trying to learn how to specify fixtures, it's very confusing out there looking through online catalogs, and different manufacturers classify fixtures differently. Some will have a link for commercial grade, some will have a link for specification grade. So how would someone, as you're looking through at all of the different options out there, be able to differentiate between the two? What's the difference between commercial grade and specification grade on the top two tiers? And I guess I'd like you each to think about that and answer. I mean, I know everybody has a different perspective, so I guess we'll start with Mark, if you don't mind. How do you differentiate commercial versus spec grade?
Sure. So your commercial grade fixtures are going to be, they're going to be obviously better quality than the good, but they're going to be permanently fastened, whether it's a welded product or a riveted product. It's going to have, it's not going to have your sharp edges to it. It might have a post-painted finish, but it could have rolled edges with a pre-painted finish. It's going to have more specifiable wattage. You're going to have more options for lumen packages. Your lensing is going to be acrylic versus polystyrene. So you're going to have better quality there. It doesn't have to be, once you start getting into the spec grade, those particular qualities are going to, upgrade further. But there's ways that we take those and put them into the commercial grade fixtures, and you're still getting a very good quality product. And so commercial grade, that's going to be more of a basic made to order fixture, whereas your spec grade is going to be a longer lead time. It's going to use even higher quality products, and you'll incorporate possibility of different metals in your housing, and you can have specification to the distribution of the product. So you might have different optics that are within the product for various distribution patterns. It's just going to be a more configurable product, in addition to the higher quality materials that are used in it.
Thank you. And from a downlight perspective, how is someone looking at your offerings and your website going to tell Brad or if they're looking at commercial grade or specification grade? What are the things you recommend someone look for?
I guess the way we kind of generically refer to it, you maybe have engineered spec versus lighting designer or architectural spec. And it really comes to, from that perspective, what the we kind of split those customers up by functionally motivated decision makers or visually motivated decision makers. So kind of the things I talked about today, once you get up to that electrical engineer level, or even oftentimes the design build level, that should be ubiquitous, right? And then as you're moving up in the category from there, it's really about the features and functions and maybe the things we can do with the reflectors of the beams and the control and things like that. As far as the longevity and serviceability of the fixture, that should be ubiquitous as you get up to that. And then as you move kind of up in the pyramid, it's the number of lumen choices, it's the beam angles, it's the finishes on the cone, and those sorts of things to satisfy, your different types of customers.
And Brad W., so as you are guiding younger up and coming folks, how would you recommend they tell the difference? I mean, setting aside pharmaceutical, which has its own set of concerns, and I don't want to say money's no object, but it plays less of a role. But if you're doing a different type of building, more of a commercial type building, how would you recommend to someone that they tell the difference between commercial versus spec grade?
Yeah, so a lot of times engineers get a bad rap. They think there goes my lighting controls shutting down. Haven't moved enough. No, so a lot of times engineers get bad raps, right? So they think, we're going to design, something that's gold plated all the time. What I tell my guys and I try to relate to them is, what we want to do is we want to work with the architect and we want to listen to what their vision is for, the space outside the clean room. Whether it's conference rooms or, cafeterias or anything like that, spaces where people are going to be. So what we try to do is understand what they're going for what they want the ambiance of the space to be. And then we start looking at lumen output and luminaire placement. So when we're looking to specify and fill out our luminaire schedules, I try to tell my guys that let's look at it from, especially right now, from a cost perspective and a lead time perspective. Here lately, I've been using what I would refer to as a contractor select in open office areas, just because the bang for the buck is there on flat panels or downlights. So it all goes to, like I said, the color output and the cost. So again, we kind of blur the line there between commercial grade and spec grade, and try to go with what meets the architect's approach to start with.
So I'm hearing a lot about taking into account sort of big picture, both finances as well as, aesthetic goals for the space and then functional goals for the space. Say I have an owner or a client or an architect who is pushing to keep it lowest cost, possible. How would you convince that owner that, maybe a step up in category is in their best interest in terms of longevity? What's the benefit to them? We're talking about cost benefit analysis here. How do you sway someone to buy a little bit higher quality fixture? And I guess we'll go back around, starting with Mark.
Sure. Well, first off, when you start getting into the higher grade products, one of the things that almost you can guarantee comes standard over the lower cost products is higher efficacy. So with the higher efficacy, you're going to have some kind of return on investment, between the two. So you're paying for the differential between the lower cost product and one that's going to, ultimately save money via energy savings. And then you have the sustainability and the repairability. A lot of the lower cost products, and we have a big issue with products that aren't serviceable, just because back in the fluorescent world, you could change a lamp and a ballast, and it was real easy. Now trying to track down the components to repair an LED product is not that easy. But there are ways to do it. And, you know, all the large name manufacturers are still supplying product to the lighting industry. You have your GEs, Osrams, Philips Advance. They're all providing products to your electrical distributors where you could get these replacement components for your products and make it as simple as it used to be without having to repair or replace the entire fixture, which you may or may not be able to get something that looks the same as you bought when you initially purchased. So spending a little bit more money in the get-go to get a serviceable product and something that has higher efficacy, that's I think it's a win-win for the customer.
So it comes down to sort of life cycle cost versus upfront cost.
Absolutely.
Yeah. Brad R., what's your take on, you know, how do you, I don't want to say upsell because that sounds like you're really pushing something, but how do you convince an owner who's sort of between better versus best, for example, in their selections?
Yeah, you know, there's a pretty good jump from good to better in the downlight world, right? You're going from this cheap plastic throwaway fixtures into kind of what we consider more the traditional, you know, downlights, you know, with the spun aluminum reflectors and the optical control. And from that standpoint, you know, as I said before, the quality of the construction and the serviceability should be there. You know, as you kind of get into that very bottom of the contractor select stuff, you kind of got to be a little bit careful. Some of them are really good, some of them aren't when it comes to that. But there are good products there. And it's really what they're looking for in the space. You know, what's the visual appeal? What are the features? You know, if they're just kind of after general illumination with in a downlight shape rather than a troffer shape, you know, there might not be reason to move up unless they're trying to match the downlights that are over in more of their maybe customer safe or more visually specific, you know, visually or higher visual requirements, you know, because there are a lot of good products kind of at that level. And oftentimes as you move to the best, it's being split up by, hey, what are the options? What can I do visually versus, hey, this is still a good product if it suits your needs. But then as you drop down below that, it tends to be a ledge, not a slope. You kind of have a slope from better to best, and then there's a drop off to, I have disposable fixtures that don't perform visually, they're not serviceable, and you're just, you know, you're not going to be happy 5 years from now.
And to take it a little bit back to the you know, specification and engineering world, Brad Watford, you know, if you have designed a space and again, setting aside sort of the very stringent requirements in some of the pharmaceutical spaces, but like you mentioned, more conference room, break room, corridor type areas. If you are getting a proposed substitution, how would you guide someone in selecting, good enough commercial type stuff in those spaces? How would you guide someone through that process to achieve the owner's goals while also maintaining appropriate cost?
So usually that comes back to me as a VE package. So I just went through this yesterday on a very large project. The clean room environment was not affected, but the rest of the space, I had a complete VE package. So again, I had to go through it and look at it for cost, and then make sure that the appearance of what was being provided as the alternate, and the lumen output, as well as the energy efficiency, still met my energy care requirements. It just depends, right? So usually, like I said, it's coming back to me as a VE package. But again, we try on the front end to be as cost effective with the owner's money. But with current times, we find that things that we thought were cost effective, based on lead time and availability, supply and demand, right? Something else is going to be potentially more cost effective.
Right. big picture versus, dragging out construction costs for the longer lead item versus wrapping it up with a slightly more expensive one we can get on site soon.
Yeah, and it all starts out, right? We try to look at it from a life cycle cost analysis perspective. I want to make sure that when we put a structure together, put a building together, like Brad said, a 10-year-old building is still a new building. You don't want to have to go into that space and start working on it immediately. You want to at least give it. We try to design for at least a 5 to 7 year maintenance cycle, because drivers are just like ballast; they're going to expire. Depends on how many times they're switched on and off in that 5 to 7 year period. So that's usually the first thing that goes.
Okay. And Mark, you had mentioned one of the advantages to an owner would be having lower energy costs. And I'm curious, especially from a manufacturer's perspective, environmental concerns are becoming more and more pressing every day. And commercial construction waste is a huge issue. And I'm curious, what are you seeing both within your company, but then also sort of just larger within the industry as far as life cycle, end of life plans for fixtures? Are you seeing any plans for that as fixtures come onto the market? I'll start with Mark.
Not specifically. The great thing about Troffers is that they are recyclable. They don't need to be recycled. We're in the retrofit business, so we design retrofit product for Troffers that have been installed for 40 and 50 years. And so they continue their life with, a new product going into it. But overall, most of the product that is utilized in a Troffer, and I'm speaking of Troffers, that are typically made in North America, are recyclable. There is a lot of product that is coming over from overseas that is using, for instance, polystyrene lenses that are not recyclable, and some of the grades of the material that are used in those. The product looks great, but it's not a sustainable product in the end.
Okay, so if that's a concern of an owner, moving to that better or best category would help alleviate those concerns. I was speaking of end of life plans from an environmental perspective. Are you seeing fixtures either that you guys are manufacturing or that you're seeing from out there just in the industry? Is it becoming a trend to have plans for the end of life of the fixture? I know there has been talk of taking them back and reusing and recycling. What are you seeing?
I can't say I've gotten a lot of requests for that specifically. A lot of the things we're talking about kind of inherently work that way, as Mark was saying. The high quality downlights are still made. You've got steel frames, aluminum reflectors, aluminum heat sinks, and they're up there for decades. When you're down there in the good, no, nobody's thinking anything about end of life on those besides where the dumpster is. The good thing is they tend to be fairly small, but every 5 or 10, if you're lucky, 15 years, you're just going to be chucking them in the trash, because even if there's recyclable material in them, you're not going to be able to get it out. Versus your more traditional, you've got a metal frame, it's easy to recycle, and there's very little non-recyclable material in a commercial or a spec grade downlight.
Right, so the fixtures that have the replaceable parts and pieces are disassemblable for other purposes.
Yeah, weight-wise, it's probably 95% steel and aluminum with a little bit of electronic components.
All right, well, we've only got a couple more minutes. If we'd like to just go around the group and any final thoughts, I guess we'll start with Brad W.
Yeah, no, on that last question, we as an engineering group try to get everybody to recycle. So we try to get everything ironed out and That's the only thing that I can say to that one. Once it leaves our hands, I don't, as an engineer, I don't really have much control over what happens
Right.
on the backside.
All right. Any final thoughts, Mark or Brad R?
Yeah, I'd say so in the troffer industry, it has changed substantially since the introduction of LEDs. In the pre-LED world, there wasn't any, I could say there with certainty, there wasn't any competition from overseas in the fluorescent world. It just didn't exist due to the cost of the fixtures and the cost of shipping here. Now you have a substantial amount of product coming in, and some of it is very good. You know, we can't make a blanket statement that all of the product coming in from overseas is not. But it is a caution that we need to look at and try to vet the best we possibly can. And in most instances with the product that I'm referring to, it's that one, they're not serviceable products. Two, it's very difficult to get specifications on drivers and LEDs being used in the products. And so it typically, those products are just something that you want to use in applications where I guess there's not a concern for, I guess I'm not going to say quality lighting, but potential issues with it.
All right, Brad Rodeghiero, we got 1 minute and you get the final word.
Just kind of what everybody else was saying, you know, with the more and more offshore fixtures in Troffers and even in Downlights and everything. It's a matter of being aware of what you're purchasing and, you know, looking for those little nuances of things that make for a quality product. And at least for a downlight, why did you purchase it in the first place, right? It's downlights in the ceiling because of the way it looks. So if you don't care how it looks, maybe why did you choose a downlight to start with? And then the serviceability and how do we make sure that it meets, you know, the life cycle cost.
Well, thank you guys. I really appreciate your perspective and participating in this panel. I picked up some great tips just from you guys talking, and sustainability and environment of where you're putting the downlight troffer or troffer-like product is really important. We had a few questions. We tried to answer as best we could. We are done with this session for today. Going back to you, Christine, to close us out.
So thank you everyone for joining us again. Make sure you take note for the half credit for this. And also I wanted to announce our next session, which is October 8th. So go ahead and mark your calendars. That's going to be same time, noon to 1 p.m. Clarification on the intent of GS 133-3. So that should be coming to your inboxes probably early next week. And with that, we will wrap it up. And thank you again for joining us and have a great weekend, everyone.